To make the door to move up or to move down, we need to work on a custom logic for it. Okay, we need to make a script for this door. So in the project window in the assets folder, we're going to right click, select create, C# script, and this is going to be named door. Okay, then we hit enter, we wait for this compilation to complete, and once it is finished, we're going to drag this script in here. Okay, so we drag and drop the door, right? And now we double click the door. So how is the logic for the door going to work? This is going to be used on several different games that you're going to develop. Okay, it's a very simple way. Of course, there are other ways. You could use Unity animations, you could use twins, but to keep things simple, we're going to work on the most simple solution here. Okay, so first of all, we're going to type private vector3 target position. Okay, so we declare a variable called target position. The type of what's going to be stored here is going to be vector3. Okay, and this vector3 is very important because when you look at a transform and you see position, rotation, and scale, all of these three properties, they are vector3s. They store a value in the x-axis, which is the horizontal axis, on the y-axis, which is the vertical axis, and the z-axis, which works as the depth axis. Okay, so when you have this set as a vector3 target position, we're going to use whatever we have stored in this variable to make the door to move there all the time. Okay, and this is very important. In the beginning of the script for the door, we need to set the target position to whatever the door is right now. Okay, and why we do this? Because if we don't, the target position is going to start as vector3.0 and the door would automatically move to the position 0, 0, 0. Okay, but maybe we want this door to be here or to be here. Okay, we can change the original position of the door, and where it's going to be, okay, in the exact place where it starts, we want to be its original position. Alright, so to do this, in the start method, we're going to type target position equals to transform.position. Okay, so wherever the door is standing right now is going to be saved. Okay, and now we need to make the actual movement logic. Okay, so in the update method, this is what we're going to type: transform.position equals vector3.lerp, and between parentheses we're going to pass transform.position as the first parameter, target position as the second parameter, and time.delta time as the third and last parameter. Okay, so that's pretty much what we have to do. So when we type transform.position equals, it means we're making an assignment, just like we did here. Okay, we're going to save whatever is in the right in the property that is defined on the left. Okay, then we do a lerp, which is a linear interpolation. Okay, it's like we're going to make a little animation. It's going to be smooth animation that goes from whatever the door is right now to this target position, and there is a time component that is going to be used, that is time.delta time. Okay, so if you save the script and go to Unity and wait for the compilation to be complete, you're going to see that, well, basically nothing special is going to happen. Okay, we press play right here and the door is standing right there. Okay, it's not moving at all. Okay, so, well, what do we need to do for this? Okay, so what we need to do is to develop a method in the door to lower it. We need to define a position where the door is lowered, and then once we look at the button needs to access the door and make it lower. Okay, so we're going to type here public vector3 lowered position. Okay, so we can define in Unity what is going to be the position when the door is down. Okay, and now here we're going to define a public void lower door. The open and close parentheses and open and close curly braces. Okay, so it's a lower door method, and once we call this method, we're simply going to type target position equals to lowered position. Okay, so we save this. Okay, so that's pretty much it. We lowered the door, and then the target position is going to be the lowered position that we defined in Unity. So let's save this. We go back to Unity, we wait for the code to be compiled, and once it is fully compiled, okay, we can set the lowered position here. Okay, so the lowered position for the door, we need to experiment here. We're going to define it as being 0 minus 5 0. Okay, so let's go back, and 0 minus 5 0. Okay, so everything we need to do now is to access that button and make that button to lower the door. Okay, so let's work on this logic. We need to create a script for the button as usual. Right click, create C# script, and then let's name this door button. Okay, we're going to hit enter to save it, wait for this compilation to complete, and we're going to double click the door button. This button needs to have a reference for the door that is going to open. So we can type here public door. Okay, and now we need to define a little method here. We can type public void on look. Okay, so if we look at the door button, we're going to call this onLook method, and the door button is going to call door.lowerDoor. Okay, so we're essentially adjusting here what is the flow of information going to look like. The player is going to look at the door button, and the door button is going to order the door to lower. Okay, and now we go to the player. Okay, so far we've been printing whatever we are looking at. Okay, so the door button, we are all seeing the names of these game objects. But what we need to do is to identify if we are looking at a door button, and if we are, we want to make it lower. Okay, so to do this, we need to type if hit.transform.getComponent of type door button is different than null. Okay, so we access the transform component of whatever object we've hit, and we call the get component method, which is basically going to retrieve any component that we can have there. So it could be transform, it could be mesh render, but in this case we want to see if there's a door button component, because if there is a door button component, it means we're looking at the door button. Okay, we open and close parentheses, as this is a method call, and want to check if it's different. This is how you write a different sign than null. Okay, so if this is true, we're going to call this method again to access the door button, and in the end we're going to call dot, and we're going to put onLook. We're going to call the onLook method of the door button. Okay, so let's save all of our scripts now. We can go to Unity and wait for the compilation to be finished. And after all of this is done, we're going to press the play button. So here we are. If we look at the button now, okay, apparently nothing happened, so let's debug that. Okay, so it's interesting to see this. Okay, so let's print in order what we are doing here. We want to see if we look at the door button, so we can type here debug.log looked at door button. Okay, we can save this, and in the door button there's going to be onLook, so we're going to call here debug.log button lowering door. We can save this, and in door we can set the position here, so we can type debug.log lowered door. That's very useful for debugging your game. Okay, just put some prints in here, and you're going to take a look at the console to see if whatever we are calling is going right. Okay, so we press the play button, we look at the button, and well, apparently no messages are being printed here. So we are having an issue here while fighting the door button script. So as you might have imagined here, if we look at the button doesn't contain a door button script, so we just drag and drop it here. Okay, and the button is going to have a reference to the door, so we just drag and drop the door here. Okay, so it's very common. Sometimes we just forget to add this script. This time, if we look at the button, the door properly lowers. Okay, so we could see all of the messages here. Looked at the door button, button lowering door, lowered door. Okay, so that means we are ready to move forward. So what we're going to do now is to make the player to enter the castle, and then we're going to put some monsters in there. So we're going to need to press the button of the Google Cardboard, or just touch the screen, to kill these monsters. So we're going to do this in the next video. To make the player move inside the castle, we're going to do a logic very similar to what we have in the door. So in the player, we're going to type private vector3 target position, and in the start method we're going to type target position equals to transform.position. So we save whatever you're looking. However, for the player, we're going to also add a public float speed. Okay, so this is going to be used for making the player move. And let's start by setting this to 0.5f. Okay, so it's going to be half of what we used in the door. In the update method, we're going to type here transform.position equals to vector3.lerp from transform.position to target position, and also we're going to type time.delta_time multiplied by speed. Okay, so it's going to move a bit slower than the door. And if you want to make the door move a little faster, you can do the same thing in the door. So you can type here public float speed. Let's set that as 3f, so it's going to be way faster. And in the update method, we multiply time.delta_time by speed. So let's save this, make sure everything's fine. And in the player, we need to define the position where it's inside the castle. Okay, so we need to actually define here a public vector3, and then let's name this castle position. Okay, so we save this, let's go to Unity, wait for the compilation to complete. Also, it is important to grab the player and move it to another vertical position like 1.6. Okay, so it's going to be more or less the height of an average human. And when the player moves inside the castle, we want it to be more or less here, okay, in the middle. So that's 0, 1.6, 13. So we write that down, and here in the player component we call 0, 1.6, 13. Okay, so we're going to use this castle position to make the player move. And the movement is going to happen once we look at the button. So when we look at the button, we want to call a method here. So we're going to define private void move to castle. Okay, and here not only we add the onLook, we're going to call the method move to castle. And to move to castle is pretty simple. We're just going to type target position equals to castle position. So let's see how this is going to look. We're going to save this, we go to Unity, and we wait for this compilation to complete. And after it is ready, we can press the play button. Okay, so here we are as players. We look at the button and we start moving inside the castle. Okay, so we are inside these doors. And now that we did this, let's make some enemies to be standing inside this castle. Okay, so what we're going to do is we're going to expand this experiment scene here. We go to our castle. We're going to right click in the castle, select 3D object, and we're going to choose sphere. Okay, so the sphere is in the 0, 0, 0 position. Let's change it to let me see, 28 on Z. So we have this one here. Let's rise it a little bit more, like this, and make it a bit bigger. So let's change its scale to 2 on all axes. So we have this. Now we're going to right click on the project window, select create material, and then it's going to be enemy material. The color of this material is going to be changed to red, like this. And now we drag and drop it here. Okay, so we have this sphere. We're going to rename the sphere to enemy and create a script for the enemy as well. So we right click, select create, C# script. This is going to be named enemy. Okay, and after the compilation is complete, we're going to attach this script to the enemy game object. So we just drag and drop here. The enemy's there. And also, to make sure that we can change enemies later, let's transform this enemy into a prefab. We just drag it and drop here in the assets folder. Okay, so the enemy is a prefab now, and we can just duplicate it and position in other places. So the objective here is going to be to destroy these enemies. Okay, duplicate that, position it here, and duplicate it one more time and position it here. Okay, so we have 5 enemies the player has to look and destroy. So how do we destroy these enemies? We're going to do something very similar to what we did with opening the door, but this time it's going to be a bit different. Okay, so this is basically the logic for looking at the door. Okay, so I'm just adding a comment here, but we want to also look at the enemies. Let's also make here moving logic. Okay, these are just comments that doesn't change your code, but they basically explain what's happening here. Now we're going to type shooting at enemies, and this time we want to check if the player is pressing the cardboard button, because since we're shooting we need to press that button located in the device or just touch the screen. So to do this we need to type if JVR viewer dot instance dot triggered. Okay, that means you're pressing the button. This returns true in the exact frame you're pressing the button, and for this to happen again you need to release the button and then touch again, so it works exactly as we want. And to make the test easier while we are on Unity Editor, we add this OR instruction here, so we can add input.get key down, and between parentheses the string space. So that means we can press the space bar as well to shoot at enemies. And now we're going to do something very similar than what we have here. So let's type raycast hit, then this is going to be named enemy hit. Okay, let's save this. And now we need to perform another raycast. If physics.raycast between parentheses transform.position, transform.forward, and out enemy hit. Okay, so let's close the parentheses, open and close curly braces, and we need to check if we hit an enemy. So we type if hit.transform.getComponent, and between the lower than and greater than signs, the class enemy is different than null. If it is different than null, then what we're going to do is basically destroy the enemy. So we just type destroy and then hit.transform.gameObject. As we looked to an enemy, we're just going to destroy it. Okay, so we're going to save this. Let's wait for the compilation to be ready, and after it is complete, let's give this a try. Okay, let's also take this time to save our scene. We now press the play button. So we're here, we look at the button to open the door, we have the enemies, and when we look at the enemy and press the space button, the enemies disappear. Okay, so we look at the 5 of them. So the whole interaction that we wanted to do here is complete. Okay, we can move the camera. Okay, so you can give some movement to the player. We can open the door and then destroy the enemies. Okay, and with this we just need to learn how to make interface for virtual reality games, so we can show some messages here. We're going to do this in the next video. For virtual reality games, interfaces can work in 2 ways. One of them, it works like we have this button here. So it's text that's standing somewhere in this 3D world. Okay, you can just look at it, it's going to stand right there, and well, it's just going to work. And another one is to make a text that is going to appear to whatever you're looking. So for instance, I might be here and there is a text at the top. If I look to the left, there's going to be the same text at the top. So there's a way to perform this illusion. What we need to do is we need to select the player. We need to right click on it, select 3D object, and then 3D text. Okay, so let's move that text to some position. Let's make it be here. Okay, so if you play now the game, you're going to see that there's hello world text, and it's going to follow you to whatever you're looking. And why does this happen? This happens because the text is below the player in the hierarchy. So if the player rotates, the text is going to rotate together, just like it works with our reticle, okay, with our crosshair. So to make this text a bit better, we're going to select it inside the player, so we have this new text here. We're going to change it to info text, and to make it be crystal clear to read, we're going to change its Y position to 50, Z to 100, then anchor to middle center, alignment to center, and font size to 120, so it can be very easy to read. Okay, it looks like it's far away from the player that you can't see, but if you press play, then this info text is going to be right at the top. Okay, and this works like that basically because of the distortion of this scene. Okay, we can see the text up there at all times. Okay, and with this text there, we can already make some changes in this game. Okay, so we need to make a game object that is going to control how everything is working here, and that something is also going to keep track of the text to say that the player, that they have to enter this castle and they have to destroy the enemies. So let's work on this. In our hierarchy, we're going to right click, select create empty. Okay, so I have this game object here. We're going to rename this game object to game controller, and we want to make sure that it's going to be in the position 0, 0, 0. So it's right there. Okay, so our game controller is there. Let's make a script to it. So right click, create C# script, and this is going to be named game controller. and once the compilation is ready, we drag the game controller script inside the game controller game object to attach the component, like this. Now we double click the script and we're going to work on accessing the text. So we can type here public text mesh info text and a semicolon to finish this statement. So let's save this, go back just to make sure that we don't lose these this reference. Okay, so there we go, info text. So I can just drag and drop it here to save the reference and also save the scene. Okay, now in the start method we can even type info text.text equals to a string. So we're going to put a text in here. We're going to say find the button and then a \n to start a new line, enter the castle. Okay, and also we need to have reference to our player, so public player because we need to see if the player has entered the castle. Okay, now in the player script we're going to make a new variable, public bool entered castle. Okay, that means the player has entered. And in the update method, when we call move to castle method, we're going to type here entered castle equals to true. Okay, so we can save this. And in the update method of the game controller, we are going to check if the player has entered the castle. So if, in between parentheses, player.entered castle, close parenthesis, we can already change that text. So info text.text equals to destroy all the enemies. Okay, so we finish this, save, go to Unity. Let's also properly assign the player in here. Okay, so we have the player, and then we can just drag and drop it here. After this, let's press the play button. So we have this message, find the button and enter the castle. Once we look at the button, it's going to say destroy all the enemies. So it's interesting now to have a count of how many enemies we still have to destroy, and once all of them are destroyed, it's going to say that we win the game. Okay, so the game controller needs to keep track of where the enemies are. Right now we have 5 enemies, but if we want to add dozens of them in here, we need to make this in a smart way. Okay, so what we want to do in the game controller is to type public transform enemy container. Okay, and we can save this. We do this because we're going to make a game object that is going to contain all of the enemies that are here. Okay, so what we're going to do is in the castle we're going to right click, select create empty, and we're going to name this enemy container, and we're going to select all of the enemy prefab instances that we have here, drag and drop them inside the enemy container. Okay, so apparently nothing changed here, but now in the game controller we can drag the enemy container to be here. Okay, so we know the transform that is the enemy container. Okay, and we do this. So in our update method, we're going to type here int enemies remaining equals to enemy container dot get components in children, okay, of type enemy, you open and close parentheses. This is going to return an array of enemies, but we just want to count them, so we can type dot length. This is how many enemies we still have to destroy. And now we can type here info text.text plus equals, as we're going to append another string. We can open this double quote and start with \n to start a new line, and then say enemies remaining colon, then another double quote plus enemies remaining. Okay, notice that I did something different here. We could have typed this entire method like this, okay, destroy all the enemies \n enemies remaining, but sometimes it's a bit more, it's tidier to just separate in new lines, just remembering to add plus equals because we're going to append another string. It works the same way. So we save this and go back to Unity. We wait for the compilation to be ready. Once it is, we can try one more time, press the play button. We can look at this button to enter. We have 5 enemies remaining, and as we destroy them, the number reduces. And notice that this is good because we can now duplicate all of these enemies if we want to add more of them. Okay, we can just duplicate all this bunch and, well, make it like this. Okay, we can put them in another position. We can change their rotation so it could be like this and this size. Okay, like they were hiding in plain sight, and it's going to show this time 10 enemies. Okay, that's pretty much the good part of programming. You can make everything customizable. Okay, and now when the enemies are at 0, we just want to say that the player won, and we're going to restart the game to start the interaction again if someone else wants to check what you did. So in the game controller, we're going to type private float restart timer, and we're going to set that as 3F. This is going to be used for restarting the game. Okay, and here at the top we type using Unity engine.scene management. Okay, now in the game controller, where we are here, we need to put this text in a condition. We need to check if enemies remaining is greater than 0. Okay, because that means that we still have enemies to destroy. So we can open curly braces and then close curly braces. Okay, and that means we're going to tell the player that we still have to destroy things. Else, that means we have 0 or lesser enemy remaining. Okay, in that case it could only be 0. In that case, we type infotext.text equals to you win. Okay, so we put this text here, and then we need to wait a little bit to restart the game. So we're going to type reset restart timer minus equals time.delta time, and if restart timer is lesser or equal than 0, that means it's time to restart the game. And to restart the game, we just type scene manager dot load scene, in between parentheses scene manager dot get active scene dot name. Okay, so we save this, we go back to Unity, and to make sure that the lighting is not going to be changed in here, sometimes we have a bug that happens in Unity Editor, we can just go to Window, select Lighting, unmark this auto checkbox, and press Build. Okay, so we do this to save the lighting data here. We can now save the scene, press play, and we can try that. Okay, so find the button, enter the castle, look at the button. We have 10 enemies to destroy, so I'm pressing space here to simulate the cardboard press. And once we look at the last one, we have you win, and after 3 seconds the interaction restarts. Okay, so that's pretty much it. With this game, we've learned how to make a very simple interactions. Okay, we know how to identify objects when we look at them, so by using the raycast, and we know how to use the trigger button. And with these 2 things, and also making the player to move, we can develop literally hundreds of different VR games. Okay, so I hope you enjoyed this lesson, and I see you next time.